60% of the greenhouse gas or the GHG emissions, and hence these are a major contributor towards the global warming. So now the question is, how do we reduce the emissions? So in order to do that, the simplest option that we can think of is to reduce the mass of the overall weight of the vehicles in order to reduce the overall fuel consumption. But however, this brings about a bigger question, that is, how do we optimize the mass as well as the strength for automotive design? This is because, as we all know, that when we look at the mass of the different materials, or rather, which is influenced by the density of the different materials for the constant volume, so we can see that there are two very common class of alloys of the metallic materials like aluminum and magnesium alloys, which are very lightweight, but definitely they have very, very low strength. And so definitely we cannot be using these materials in order to design the automobiles, especially the structural parts of the automobiles, which need very, very high crash resistance for ensuring passenger safety. So the only option that we have with us is to use the advanced high strength steels, especially the aluminum alloyed advanced high strength steels, which can basically reduce the mass by around 15 to 25%. So, so definitely when we use the word aluminum alloyed advanced high strength steels, this aluminum addition or the aluminum alloying basically leads to the mass reduction, and the other elements present in this alloy induce the strength in this material. So, so definitely we can plan to use these steels in order to design the components, structural components with enhanced crash resistance. So, so having known this, the research methodology my research methodology is as follows. That is, I have added a number of different alloying elements, for example, iron, manganese, carbon, aluminum, and nickel, and basically synthesized an advanced high strength steel and an aluminum alloyed FEM and NIC advanced high strength steel. So having synthesized that, the bigger question is, what is the atomic arrangement of the different alloy elements present in the HSS? It's very crucial to understand because it influences the mechanical properties directly of the steels. So, so the objectives that I've devised for my PhD thesis is as follows. That is, I've used a number of microscopy techniques ranging from the bulk to the near atomic scale towards understanding the atomic arrangement of the different elements and how this atomic arrangement influences the mechanical behavior. And this is very, very indispensable. This understanding is rather very indispensable for the service life prediction of the HSS. So, advanced high strength steels. So, with this, I would like to conclude. Thank you.